Alrighty, we are back, ladies and gentlemen, with another Algebra 1 state test review. Today we are doing standard A.CED.2, and we're starting off with a bit of a doozy, so let's hop right in. From the practice OST. A scientist is studying wildlife. She estimates the population of bats in her state to be 270,000. She predicts the population to grow at an average annual rate of 2.9%. Using the scientist's prediction, create a model create an equation that models the population of bats Y after X years. So what do we know? We know our starting value is 270,000. We know that it grows at 2.9%. So 2.9%, we're probably going to want to convert that to decimal form. So let's do that now. Remember to convert something from a percent to a decimal form. You grab the decimal point, move it to the left exactly twice. So that would be 0.029. And we know that we're looking to create an equation for the population of bats Y after X years. Please note this is very important. I've said this in previous videos, but this is very, very important. If the question defines the variables for you, for example, if it tells you that the population of bats is Y, you must use Y for the population of bats. Just like you must use X for years. Why do I say this? Because when you look at a typical formula for exponential growth, which is what this is, typically you're looking at your initial value y equals a1 times 1 plus r to the t, where t represents time. But here they tell you that you're going after x years, which means you cannot use t. You must use x. So remember what each of these represents. A1 represents the beginning, the first term, the start, the starting value, whatever. R represents your rate of change. T represents time. Okay? So, to write an equation, we would put in y equals our starting value, which we know to be 270,000, times 1 plus our rate, which we converted to decimal form, 0.029, to the x power. Again, you cannot put t. If you put t here, you will be marked wrong. You must put x. And that's going to become even more apparent in our next question. Stephanie adds pennies, nickels, and quarters to a scale until the mass of the combined coins is 75 grams. Each penny has a mass of 2.5 grams, each nickel a mass of 5, and each quarter a mass of 5.7. Create an equation to model this situation where x is the number of pennies, y is the number of nickels, and z is the number of quarters. Okay? So, when you look at this question, right? The first time I did this question, which was before the OST in December, what I did was I put in P for pennies, N for nickels, and Q for quarters. And that's great and all, but you can't do that because they tell you that X is the number of pennies, Y is the number of nickels, and Z is the number of quarters. So, what are we looking to know? Create an equation to model this situation where X is the number of pennies, Y is the number of nickels, and Z is the number of quarters that Stephanie can put on the scale so the mass of the combined coins is exactly, that means equals, 75 grams, okay? So because our total is in grams, is exactly 75 grams, we know that we're working with the weights. The fact that they're pennies and nickels and quarters doesn't matter. All that matters is how much they weigh. So, our equation is going to look like this. 75, that's our total, equals the total mass of the pennies plus the total mass of the nickels plus the total mass of the quarters. Each penny is 2.5 grams. So 2.5x, where x is the number of pennies. Each nickel is 5 grams. So we'll say 5 times y plus 5 times the number of nickels. And each quarter is 5.7 grams. And z is what we use for quarters. So 2.5 times the number of pennies gets you the total weight of the pennies. 5 times the number of nickels gets you the total weight of the nickels. And 5.7 times the number of quarters gets you the total weight of the quarters. When you add all those up together, you should be getting 75. This is your answer. Doesn't ask you to solve, just asks you for a plausible equation. All right, question 3. Madison bought B pounds of bananas and P pounds of pears and spends a total of $10.38. The price of bananas is $60 per pound. I'm sorry, 60 cents per pound. The price of pears is $1.74 per pound. Create an equation. This one's actually remarkably more simpler than the last one because there's only two variables we have to worry about. Now, once again, they define what the variables are. You are using B for bananas, and you are using P for pears, okay? So the total is $10.38. That means we're working with money. $10.38, okay? Equals. That's the total. When you think about what makes up your total, it's how much you spent on individual items. So the amount of pounds of bananas plus the pounds of pears, okay? Now, what do we know about what we're going to put in the equation? Well, since we're working with money in the total, we're probably involving the money somewhere in here. They give you bananas is 60 cents per pound as a rate. The pears is $1.74 per pound, again, as a rate. So let's just put in what we have. Put in exactly what they give you. The total cost is 60 cents times the number of bananas, the number of pounds of bananas that they bought, plus $1.74 times the amount of pounds of pears that they bought. Simple as that. Done and done. The biggest thing with these problems is that they want you to overthink, right? They want you to overthink these. And this is one that you could very easily overthink, but the answer is remarkably not complex. All right. On to question 4. Farah scored 42 points in a recent basketball game. She made only 2-point shots and 3-point shots. In total, she made 19 shots. Create 2 unique equations that model the number of 2-point shots x, excuse the yawning, it's been a long day, and the number of 3-point shots y that Farah made in the game. Okay, so they're looking for 2 equations, and this is what I like to call a 2 totals problem. We have 2 different types of totals. We have number of shots, and we have number of points, okay? 2 points, 3 points. They scored 42 points and made 19 shots. So what you have to do, right, is you have to keep the shots with shots and the points with points. How many points are each shot worth? Well, we have 2-point shots. So the amount of points they got for that would be 2 times the number of 2-point shots they made. So 2x, I hope that makes sense. And the number of 3-point shots, y. So you have to take the number of 2-point shots and you have to add 3 times the number of 3-point shots they made. Because if you only account for the number of shots they make, you're only going to give 1 point to this. You need to make sure you're giving 3 points per 3-point shot, in the same way that you're giving 2 points per 2-point shot. Equals the total number of points that they scored, 42. That's our points equation, okay? When you see a question like this, I want you to break it into the points equation and the shots equation, okay? Our shots equation is going to look a little different, because when you analyze the shots, you're not so much worried about how many points the shot was worth. You're just worried about how many shots. They took a number of shots equal to their number of 2-point shots plus their number of 3-point shots, and they took 19 shots total. It doesn't matter how many points the shots are worth. You just need to account for the fact that they are shots. All right. On to question 5. A rectangle has a length of k plus 2 inches and a width of k minus 2 inches. Create an equation that can be used to find the area A in square inches of the rectangle in terms of k. Well, this question is remarkably easy when you have to consider that the area of a rectangle is just length times width. Okay? So your length is k plus 2 times your width k minus 2 That's it. Could you go further? Yes. Could you do FOIL method or area method to find out what this is in the least amount of terms? Yes. Do you need to? No. Should you? Not really. If it doesn't ask you to do so, don't do it. Why risk getting it wrong? If all you have to do is just do k plus 2, k minus 2, you good. That's it. So that is this standard. I hope it was helpful to you. If you have any questions, as always, please let me know. And good luck on your state test.